It's one of those good news, bad news situations, folks. The good news is the Leaf battery is now off the truck. The bad news is, in doing so, we blew our first hydraulic line on the JCB. Hello folks, welcome to International Day of JCB Fixing. What should have been a simple job, using said JCB to remove the Leaf battery from our truck, was going absolutely swimmingly until we blew a hydraulic line in the back actor. And I'd originally, judging by the pool of fluid in here, thought that it was one of these lines in here that had gone. Not so, that would have been way too easy. Turns out it's the line that connects to that ram to the return side of that ram, and it comes all the way down here through this thing, through various pipe clamps, attaches on here to a hard line at the bottom. So I had to wrestle that out. You can see here where it's blown. Great fun. So we just got back now from my local hydraulic shop. We got a new hose made up and some extra hydraulic fluid, because we did manage to dump out a drop or two here. So I'm going to wrestle this hose back in, top up the fluid, and see if we can see if we can complete the plan of taking the battery out of the truck, so that I can bring the truck down to the workshop and do these few frame repairs before we put the front mounts for our battery in. Also carve out this piece here, a little tunnel in here for our cables. So yes folks, all the fun of EV conversion, oil free, a day at a time. Okay folks, this was never going to be easy. This is, as we all know, a 1969 JCB 3C Mark II. It uses Imperial hydraulic fittings. These guys here, they're all 5/8 BSPT. My hydraulic guy, on the first time around, had put 16mm metric ends on the new hose. So I'm just back. We've got another hose made, which now has 5/8 BSP. So let's go ahead and fish this back into the boom and see if we can get this thing moving. So we want to go, yeah, like this. Stop there. Okay. Alright. Wish me luck, folks. Let's see if this will tread up onto the ram up here. Please tread up. Please. Please. Really? Let's shake hands with danger. There we go. Alright, that looks good. Let's hope there's only one hose going. Now there's not a second one. Oh man. Just one at a time, JCB. Just one at a time. You can blow one hose at a time, and then I'll replace them one hose at a time. Is that a fair deal? Oh yeah, let's shake hands with danger by leaning over. Damien believes that nothing bad can happen to him, and after all, he's in a hurry. It's a really warm day. This is why Damien decides today to shake hands with danger. Okay, what could go wrong? Got to replace this filter element as well, but that's not for today. For my leg, ideally. Yeah, pretty much. Brilliant. Well, there we have it, folks. Boom is down now on the ground. I've got all the pipe clamps back on, and battery is finally out of the back of the truck. That only took about 5 hours. What I had allocated about 15 minutes. So there we go. Day one, not so good. So the first little bit of needle gun work here. I always like using the needle gun wherever there's corrosion, because not only does it clean it off, but it kind of punches out anything that's kind of weak. So let's see here, we have a few weak spots. We're going to have to cut them out. But needle gun is one noisy sort of a thing, but it does get into those hard to reach places. Oh yeah. That's there we go. Alright. Well, there was an absolute ton muck and dirt and rusty bits in there. We got them cleaned out. I've hit the inside of it with some of this rust converter stuff. I'm not expecting much, but it'll be better than nothing. Got ourselves a patch now, so we're gonna this guy in, tack him in, and get him welded up, and then we can fix this little bit here, and then this will be this side done. Woohoo, we're a bit warm. Yeah, I'm a little bit warm. Okay. There we are. There we go. See, that's all stuff there that we just don't need. Oh yeah. Look at that. Don't need any of this. Plywood or something. Don't need that. Oh yeah. Not even going to damage the seat. Oh, what's that? Oh. Freebies, even after all these years. Nice. Okay. Let's see if this is going to work. So some MS polymer adhesive and a bit of aluminium here. I think it's like 2 or 3 mil aluminium. And we'll get that in there. Perhaps, he said. Perhaps. I'm going to try and get back a bit. Yeah, that's what I'm kind of looking for. Something I can wedge like that. There we go. Oh, much to my surprise, that actually seemed to work. Shocker. That'll give us oh, hello. It'll give us something to grip onto there. Get a blob in there and go around the other side. Then once that goes off, be able to cut some sides, put them in there. Knob on that. Knob on that. Alright. Alrighty. We're done. I ended up not going out to get MIG wire after all because it just takes time. And I'm quite low on gas as well, so I figure by the time I go and get the wire, I'd run out of gas. So I had a bit of flux core wire lying around, so I finished it up with that. Did a reasonable job. You could argue flux core is better on contaminated material anyway. So we got our rusty bits all cut out, fresh metal in and seam welded in. It ain't pretty, but it'll definitely do the job. Just put a bit of cold galv on the new metal there, just to slow down the old channel sponsor. And likewise over here, cut out the bad metal and seamed in a new piece. So this will be roughly where our front battery mounts will weld in. So you can see that's why I had to do these repairs now anyway. I mean, they had to be done anyway, but this is why they had to be done now before we'd have the battery fully in there. Obviously with our little tunnel chopped out and some aluminium in there, just sealing that up. I've just got a bar holding that in place just till the MS polymer goes off. So that'll come out tomorrow. With a bit of luck then we can get the battery back on here and get the front battery mounts welded to the frame, and then that is the battery in here for the purposes of getting this vehicle moving under electric power. So depending how we go then tomorrow, I think it's going to be a wet day, so we might end up doing a bit here with the coupler and the adapter plate. A couple more things to do there. But yeah, once we get the battery in, with this guy ready to bolt up, we'll be in a good spot. Hello folks. So the time is upon us, finally, to get our drivetrain ready, or I guess power plant as it were, ready for our truck. So, as we will see, and much to my shame, the date on this parcel here is the 24th of the 4th, 2023. We're in the middle of June 2024 now when I'm making this video. But what we have in here is an adapter plate and a coupler for the Nissan Leaf EM57, which is what these motors are here, from Dala Industries. Now, very kindly provided this to me, and it's been over a year that I've had this package here, and I haven't actually done anything with it. But we are finally getting there. Now you might ask, what's with this metal plate here and the piece of steel pipe? Well, the reason is that Dala Industries actually are one of the few companies working on any of this adapter plate stuff that actually publish the CAD drawings for some of their adapter plates. And obviously the most useful one here is this one for our Nissan Leaf EM57. And this one here has been cut out of 6mm steel for me by a local small business that has a CNC plasma table, which is really useful. Now, in order for me to try to give some stuff back here, I've also designed some plates here that will bolt up to the Leaf motor mounts, the EM57 motor mounts, both the rear and the front, and I'll be publishing those designs also. Anyway, main thing we need to do is we need to get our motor and our gearbox coupled up. Now normally I do these the kind of more conventional way, but on this project I've decided to see if we can do things a little bit differently, so that it means less kind of grunt work for me, but also means that then I can share some of these designs with the community and kind of maybe help other people along the way as well. So let's first of all, we'll look in our Dala Industries box here, because Johannes isn't the only one that gets to do some unboxing. So we have some stickers for our two projects, because we'll be using the Leaf motors in both the truck and E92, so we got some stickers for both of those vehicles. And right in here you'll see this is my clutch center that I cut out for the Mitsubishi L200 gearbox, so we got that part. And right here in the middle, this is our proper Leaf motor coupler that Dala Industries supply, and we'll show you all that on their website. And this is our coupler. It's got the Leaf splines and a blank here, and despite that being a bit rusty, pops straight onto our Leaf motor there. And there we go. Now also in here, very kindly sent to me, is a CNC machined aluminium adapter plate for the EM57 motor. Now this has even got the dowel in it for going on there. Now we're not actually going to be using this in this particular project. We'll keep this because there may be a future project for it. Instead, oh yeah, clutch center. Instead, we are going to be doing this with mild steel. And the reason is that in the cases where we want to retain the Leaf stack, where we have the PDM, we need to step the motor back so that the gearbox bell housing falls on this kind of a line here, or even a few millimeters more than it. And that's the purpose of this piece of, I think it's like 180mm steel pipe. So what we're going to be doing in a few minutes, just take some of these bolts out here. We're going to be doing, there we go, is we're going to take our steel version of the plate, going to sit that pipe, going to center it up roughly on there and get some tack welds on this guy. Okay, so now we've got that guy. Should be able to just stick a few bolts through this and get a rough idea. Ta-da! One fancy cadded adapter plate for the L200 gearbox. And this guy will go on here something like this. So some line up kind of a scenario, and we'll basically have our gearbox side probably with this guy going across the top, but I'll have to look at that when we're actually doing it. But anyway, okay, so I've thrown the bell housing just back on here. Got our clutch center. I'm going to sit that on there till it's about roughly midway on the splines that we have there. Got our measuring tape and our straight edge again. We go from that surface there, and that's 50mm. So 50mm from that front surface brings us to bell housing, and we just measure that a second time, and yes, that is indeed 50mm. So let's make a bit of sense out of this now. We now know that to get from the face of the coupler to this face on the bell housing is 58mm. And to get from the face of the bell housing to this part here is 58. So the next part that we need is this little step back here. We need to measure this and see how much of a step back we need on there. And that is pretty much bang on 10mm. So we're going to go ahead and add 10mm on clutch end for a step, we'll call it. Step back. Okay. And then we're going to have a look at our Brat Industries coupler here. Going to look at the diameter of that, which is roughly 40mm. So I would want to go over this to really get a good squeeze on it, at least 20mm, so half of that diameter. So I'm going to make it 25 to go over this. So that's going to be in there. And I'm going to say 25 here's on leaf coupler. Right. That's it. It's bottomed out. So, one Brat Industries coupler, one L200 clutch spline. Huh. Well, that was great fun. Nice dry day for it too. Got a battery on the back. Let's see if we can drive down to the workshop without it falling off the back. Right, let's give me some 2 high here. Give me some of that. Give me some of that. Give me some of that turbo, baby. Maybe the AI will do a better job. Yeah, there it goes again. Battery refitted. Now all we got to do is weld on the front mounts. We got to get these nice bolts back in. Weld on the front mounts. So folks, I am hoping we'll be able to get Rain to join the channel in a regular sponsorship slot for us. But until this actually happens formally, we just thank the Rain for dampening down any unnecessary welding sparks that we may now create. Thanks, Rain. Looking forward to seeing you on the channel again soon. Okay, folks. So we're back here with our adapter plate coupler setup, and you'll have seen there that what I decided to do was to make up a 3D printed version. So I actually did a drawing for this, and I did a 3D printed just a PET plastic version of the piece that I have to get made in order to adapt our L200 gearbox onto our Nissan Leaf motor. Now, there's a few things here that I'm not going to cover in this video because it's already getting long enough, and also there's a few things I don't have here. So when we're next looking at this, we will have some progress on this. I'll have this made out of steel. I'm going to be sending that kind of template or mock-up or whatever you want to call it to a friend of mine to have him make this out of steel and sweat fit the parts together and weld it up and so on. So with this made out of steel, then we'll be coming back to the whole topic of adapting on our L200 gearbox. So like I say, we'll be doing it this way on the, be doing it a certain way on the L200 and doing it a slightly different way on the Plastic Panzer project. So hopefully we'll be able to show you here a few different variants of how to do the same job. So like I said, I'm not going to go on too much more about this, but we will catch this part up in the next semi-exciting episode. So here on the truck now, we've our battery fully mounted in 3 places each side. So we got 6 16mm bolts holding this thing on, so don't think it's going to fall off. Frame repairs done, as you saw, and we made our little tunnel in there now, which hopefully you'll be able to see better, which gives us a place then for connecting our high voltage and BMS cables, bringing those down underneath the vehicle. So we'll obviously have to make a longer cable because it'll have to come in under the cab and come on up into the engine compartment here. So I'll get that cable, I'll get all of these cables in. I can kind of tuck them away here at the side before we even disable the diesel engine. So I'd like to think that in the next episode on here we will have our motor coupling done, we get our cables in so we can communicate with the battery, because I have to write some code for the Zombiverter VCU to talk to our Nissan Leaf BMS here. Translation, going to rip off what Johannes did, delete all of references to him, make it look like I did it all, and make lots of money. So anyway, don't tell anyone about that, obviously. So that's the plan for the truck, so that'll be the next episode, and hopefully then the episode after that we'll be taking that engine out and putting our fully assembled 110 kilowatt Nissan Leaf stack in there. So folks, apologies this video went on bit long. As you could see there, we had some various problems, be it weather, be it the JCB blowing the hydraulic line, and me just being generally stupid. So I will close out by saying, as always, don't forget to check the links in the description to the Open Inverter forum. Patreon and PayPal, don't go near those, because if you give me any more money, I just do more of these kind of stupid projects. And also there'll be links in there to Brat Industries, as I say, who kindly supplied me the coupler and that adapter plate. They also have a whole range of adapter plates and things there, and I said one of the things I really like about them is that they publish the drawings. So hopefully now that I've been doing a bit of CAD work with these leaf brackets and adapters and stuff, I'll be able to feed some of that back into the community as well, so that we try and avoid duplication. So there's the truck, and until next time, happy open source code ripping offing.